Good morning, grade 12s. We have a very interesting calculus lesson today, and we're going to be focusing on the remainder and factor theorem. And you'll notice how that leads us very nicely into factorizing the cubic expression, because the aim is we want to draw the cubic graph. So let's go straight in, and let's take it from what we know already. You may recall from previous grades, we started with the straight line function. And there the formula is given to us, as you can see on the monitor, y is equal to mx plus c. As an example, f of x, which stands for y, is equal to x minus 3. What does that graph look like? Well, here it is right here. You'll notice very clearly that here we have our minus 3, and that links to the y-intercept there. The gradient is 1 because if we take positive 3 and there we have minus 3, remember minus 3 divided by positive 3 will give us positive 1. So in a very real sense, our gradient there is positive 1. And so moving on, here we have the parabola. The parabola is given by the equation y is equal to ax squared plus bx plus c. An example of that function is f of x is equal to x squared minus 2x minus 3. Now that parabola, when drawn, looks like this. Here we have the y-intercept, minus 3, which links to that particular point there. And then our x-intercepts, if we find the x-intercepts of this parabola, the x-intercepts, as we can see drawn, are minus 1 and positive 3. Now that's what we know from grade 10 and into grade 11. What about grade 12? Now we have the cubic expression. As you can see on the monitor, y is equal to ax cubed plus bx squared plus cx plus d. An example of that is f of x is equal to x cubed minus 2x squared minus 5x plus 6. Now, what does that graph look like? Well, here it is. And this may be a very brand new concept for you in grade 12, because now, notice this particular graph has got 3 x-intercepts. And we're not surprised, because the defining expression there is x cubed. So we know that there should be 3 places that it cuts the x-axis. And so our lesson today is going to focus on the remainder theorem and the factor theorem. Firstly, what is meant by the remainder theorem? Well, the remainder theorem states that if a polynomial, f of x, is divided by a linear polynomial, ax plus b, then the remainder, r, is represented by the expression, and there we see the expression coming up now. R is equal to f in brackets minus b over a. You may be thinking, that still looks very complicated for me. Let's do an example and see what we mean by this. Well, here we have our example. Notice what we are given. We are given f of x is equal to x cubed plus 5x squared minus 2x minus 24. And so we need to determine, firstly, the remainder of f of x when we start factorizing it when divided by x minus 2. Notice that x minus 2, if we take that, we make that equal to 0 and take the minus 2 across, x is equal to positive 2. And so if we substitute that positive 2 into this expression, wherever we have x, we're going to have 2 cubed plus 5, 2 squared, minus 2, multiplied by 2, minus 24. If you put that in on your calculator, you'll notice that the remainder is 0. What is our conclusion? Well, when f of x is divided by x minus 2, the remainder equals 0. And when that's the case, x minus 2 is a factor. So that brings us very nicely to the factor theorem. In words, the factor theorem states that if f of x is a polynomial and it has the factor of ax plus b, then f of minus b over a is equal to 0. So what does that really mean for us? Well, notice this example. Here we are given this cubic expression. F of x is equal to x cubed minus 4x squared plus x plus 6. Taking that one step further, we need to determine which one is a factor of f of x and state why. Well, look at that one. Firstly, we are given x minus 1. Do you think that's a factor of that cubic expression? Well, we're going to find out. Or x plus 1. Do you think that's a factor of that cubic expression? It looks like we're busy with some sort of guesswork. X minus 1, x plus 1. Well, let's find out. Firstly, there we have our expression. F of x is equal to x cubed minus 4x squared plus x plus 6. Step number 1. We need to test whether x minus 1 is a factor or not. Well, if we take that x minus 1 and make it equal to 0, we notice if we take the minus 1 over, x will equal to minus 1. So if we substitute that minus 1 into the cubic expression there, we're going to have 1 cubed minus 4, 1 squared, plus 1 plus 6. What is our remainder? 4. Is this a factor? No, definitely not. Why is it not a factor? Because the remainder is not equal to 0. Do you have that, grade 12s? That's a very important point. If a value of x is substituted into the cubic expression and we have a remainder, a number not equal to 0, well then that is not a factor. Let's go back to our example. Look at this one here. Remember, we had the second one. We had to test whether x plus 1 is a factor or not. Well, there we have x plus 1. We take that plus 1 over, and therefore x is equal to minus 1. If we substitute minus 1 into this expression here, there's minus 1 there. We have minus 1 cubed, minus 4, minus 1 squared, plus minus 1 plus 6. Put that in on the calculator. The remainder is 0. The calculator will tell us that. Is this a factor? Yes, it is a factor. Why is this a factor? Because the remainder is equal to 0. Very important point. So when a factor, when an x value is substituted into a cubic expression and the remainder is 0, that is a factor of that cubic expression. Now, fortunately for us, there are 3 methods from which to choose for us to factorize cubic polynomials. If you look at the monitor, you'll notice these 3 methods are listed. Firstly, we can do so by inspection. And then secondly, we can use long division, as you can see there. And then thirdly, synthetic division. So once again, inspection or long division or synthetic division. Now, any one of these 3 can help us factorize a cubic polynomial. What we are going to do today is we're going to focus on the inspection method, which I think is really the easiest to use when factorizing a cubic polynomial. Notice this example given. We are asked, solve for x. F of x is equal to 2x cubed minus 3x squared minus 2x plus 3. Step number 1, we first have to use the factors of the constant term. You see that positive 3? That is the constant term. We use the factors of that term in the cubic expression. Now we know the factors of that positive 3 are minus 3, minus 1, positive 1, or 3. And we substitute each of them individually into this cubic polynomial to see whether the remainder is equal to 0. Only when we get 0 on our calculator do we know that that is definitely a factor. Step number 2. Next, we have to factorize using either inspection long division or synthetic division. You may remember those are the three methods that I just mentioned. And then thirdly, we have to then write down our values of x. So how does this look in practical terms? Well, let's give our attention to this example. Here we are asked to solve for x, and we are given this particular cubic polynomial. F of x is equal to 2x cubed minus 3x squared minus 2x plus 3. Firstly, we look at the factors of that positive 3. And I've chosen to substitute x is equal to 1 into the cubic expression. Well, what happens when I do that? Well, notice what I do. I say f1 because that x is equal to 1. So I put the 1 there where the x should be. 2, 1 cubed, minus 3, 1 squared, minus 2, 1, plus 3. Taking it further, my remainder is 0. What does that mean? Well, that means that x minus 1 is a factor. Now, grade 12s, if I can just draw your attention to something. If, for example, we say x is equal to 1, and we find out that that is definitely a factor, right? In other words, the remainder is 0. Well, if I have to take this 1 over, I'm going to have x minus 1 is equal to 0. You agree? Therefore, I can conclude that x minus 1 is a factor of that cubic polynomial. That's a very, very important point. Do you notice? If I substitute x is equal to 1, I take that 1 over x minus 1, and when I write that down, x minus 1. We need this for the next step where we are going. Well, if we look back at the monitor, now we have a very interesting situation. We've got a situation where we have one factor here, x minus 1, and then we know that the next factor has to be in the format of a quadratic expression. The reason for that is this is cubic. So 1x multiplied by x squared will give us x cubed. So this has to be a cubic expression. And you may remember from previous grades that the quadratic expression is given by the equation ax squared plus bx plus c. So now how do we factorize this? Well, if we have a look at this, now we have an interesting situation, right? Initially we have f of x is equal to 2x cubed minus 3x squared minus 2x plus 3. We have just established that x minus 1 is a factor. X minus 1 is a factor. How did we establish that? Well, we substituted positive 1 into all these x values, and we found out that the remainder is 0. So therefore, x minus 1 is a factor. So now, here we have a very interesting approach that happens here. As I mentioned, we have to have a quadratic expression. So 2x cubed divided by x will give us a 2x squared. Do you agree with that? I'm sure you do. And then we go to the last term and we say positive 3 divided by minus 1 will give us a minus 3. Yes, I can hear you saying that. Now, how do we find the middle term of this cubic expression? We know it's going to have an x because here we have 2x squared, we have an x squared, this must be x, and we have our constant term as well. Well, this is now where we use inspection. So the best way to do it is to always say plus bx. In a very real sense, we don't know what this value of b is going to be. And now what we do, grade 12s, is we use this very interesting method. We are now going to multiply these two here, and then we're going to multiply those two, and then we're going to go back to our original expression, and we're going to have a look at our x squared there. Now let me take this nice and slow for you so that you see. Firstly, what is minus 1 multiplied by 2x squared? I can hear you saying it. Yes, it's minus 2x squared. Well done. What is x multiplied by positive bx? You're right. It's plus bx squared. And then I have to make that equal to my original minus 3x, because this belongs to the family, one can say, of the x squared. So I bring this one down here. If I have to just draw this, I just draw a little arrow here and I bring that down there. And so when I do that, I'm going to make that minus 3x squared. Do you notice I have a common factor in each of them? I have x squared, x squared, x squared. So in a very real sense, in my next step, I can just knock out all the x squareds because they're all the same. And what am I left with? I'm left with minus 2 plus b is equal to minus 3. When I take this minus 2 over, that becomes positive 2, you remember? So minus 3 plus 2, b is going to be equal to minus 1. And that's how I find my value of b. So if I have to write now this expression once again, well, it's going to look something like this. I'm going to have x minus 1, and then I'm going to have 2x squared, I had that already, minus x minus 3. And now I can simply factorize this, and then I can have 3 factors for my cubic polynomial. So on the monitor, here we see how we got that. I just illustrated that on paper because you may wonder, how does the inspection method work? But here we see it, minus 2x squared minus x minus 3. So if we take that one step further, when we factorize that, this is easy work. We've done this even in grade 8, in grade 9, grade 10, factorizing a quadratic. And there we have f of x is equal to minus x minus 1, x plus 1, 2x minus 3. And therefore, what are we saying? Well, x is equal to 1 from that one. Then x is equal to minus 1, and x is equal to 3 over 2. Those are our x values. Now, this is how we do factorizing of cubic polynomials. There's an exercise that we can try. Notice we are given g of x is equal to x cubed minus 4x squared plus x plus 6. Firstly, we have to prove that x minus 2 is a factor of g of x. Well, we know what to do. We substitute x is equal to 2 into that cubic polynomial. And when we do that, we have our remainders equal to 0. Therefore, we know that x minus 2 is a factor. Our next step is to factorize fully. And so then we take it from there using the inspection method as I've just illustrated. And if you follow that method that was outlined, you'll notice you're going to have g of x is equal to x minus 2. Next bracket is going to be x squared, which is 1x squared, minus 2x minus 3. And there we have g of x is equal to x minus 2, x plus 1, x minus 3. And that brings us to our x values, which are the x-intercepts of this cubic graph. X is equal to 2, or x is equal to minus 1, or x is equal to positive 3. In a real sense, that is where the cubic graph will cut the x-axis. Grade 12s, if this information has come very fast for you and maybe you felt that you've been left behind, you can always watch this video again. But factorizing the cubic polynomial is a very important part of grade 12 work. Remember the 3 methods you can use. The one that we chose today is inspection. So always make sure that you work in harmony with accurate mathematical principles. All the best with your studies and keep working on your mathematics. Bye-bye.